For part A, if the angle is known, what's the distance of the board? So I'm going to take this as the y because there's another d already right there, so I can't use d. And what is the distance of the board? So I'm going to use the h max equals to v squared sine squared theta over 2g. And however, this equation is only for like drawing an object in the air, but this object is on a ramp, so instead of our gravity we have to use the acceleration going downward in the y direction. And if we take this as I'm gonna label this as gy. Actually, I'm gonna label this as gx and this as gy. And the reason why I'm labeling this direction as gy is because I'm going to take the vertical direction up and down my length as the y direction. And so sine of theta, this is theta. I'm going to be calling this theta 2. Sine of theta 2 equals to opposites gy over gravity, multiply gravity over, to get gy equals g sine theta 2. And so our vertical distance up the ramp, dy, equals to v squared sine squared theta over 2 g sine second theta. For our next question, what is, without any dependence on that, so we cannot use the range function, but it says to consider the horizontal motion, and there is vx going in the horizontal direction, and as there is no friction and no acceleration acting in the direction of vx, I can say that vx over time equals to your distance, your horizontal distance d, and this asks us for the time, so we simply isolate for t. Why did I divide this? It's vx times t. I divide vx over, so your time to get to target, your time total equals to your vertical distance, not vertical, horizontal, your horizontal distance over your v of x. But what is v of x? V of x, if this is your hypotenuse, this is your theta, and this is your adjacent side, v of x equals to v of x equals to v o cosine theta. So your time total equals your horizontal distance over v0 cosine of theta. For part C, it asks us how long it would take to reach the maximum height. Since this the acceleration is constant, I'll be using the my A equals VF minus VI over T. A equals VF minus VI over T. And since we want to get the maximum height or the peak, we know that I'll be taking this equation from the vertical direction, by the way, the y direction. We know that the peak, your velocity in the y direction is 0 because it's a critical point. So therefore, I can claim that A, which we know is g sine of the second theta, g sine of the second theta equals to VF at the peak, which we know is 0. So it's just minus VI in the vertical direction. Because it's in the vertical direction, I'm just going to redraw the arrow right here. That is offset over hypotenuse. So that is V0 sine of theta. And that's over T. If I multiply T over and divide that, get T equals to negative V0 sine of theta over G sine sine G sine of the second theta. Just one more thing I would like to add. G is taken as negative in this scenario because time has to be positive, and the top V0 sine theta is negative. For part D, the answer is that. How much time does it take to hit the target? So this is quite simple. It takes 2 delta t. And the reason for that is because, as I said before, Vx is constant. And therefore, that the H max, which is d over 2, as this is a simple parabola, as acceleration is constant, and therefore, if this is half the time it takes to get here, and this must be twice the time. Anyways, for part E, prove that that should be that. Well, I see D being used in this equation, so I'm gonna assume that whoever made this equation took it from the vertical standpoint, not vertical, horizontal standpoint, because D is the horizontal. So I am going to use the range equation is V0 sine 2 theta over G, but G is different in this scenario because it's a ramp. And let's see, oh, I forgot the square. And in a scenario, the distance equals to VO squared sine 2 theta over the GY in this scenario is going to be G sine of the second theta. And let's see, so we want to get GD sine of that theta over that square. So I'm going to multiply the G sine of the second theta over, so it's GD sine second theta equals to V squared sine 2 theta. Gonna divide V squared over, so that's V squared And I'm gonna take the inverse sine of this, so sine -1 of g d sine of the second theta over v squared equals to 2 theta, and then we divide the 2 over, so that gets us 1/2. Maybe right over here so it's clear. 1/2 sine -1 of GD sine of your second theta over V0 squared, and that does indeed equal to that. If the angle is increased, how would the answer to part A change? What would we do for part A? So we said that dy equals to V0 squared sine 2 theta over 2g sine of the second theta. And it says this angle is increased. And since we know that the angle is from 0 to 90, and that if this is the unit circle and sine theta is the y-axis, if the angle is small, the y value according to small, and if it's bigger, then the y value that points to that is bigger, so that we know as sine approaches 90 degrees, its value will increase. And as this increases, and it's at the bottom of the fraction, so therefore dy is going to decrease.